Thank you for the host. Hello everyone, it's glad to have this opportunity to share some thoughts and works we have done recently. And today I'm here with my teammate Goli. And we are from the IBM analytic groups that we're focusing on the analytic algorithm design, researching, implementation, and also related output visualizations. We offer these algorithm modules to be integrated into several IBM analytic products, such as maybe you have already heard of the SPSS modeler, SPSS statistics, and also the Watson Studio, which named as the data experience, data science experience before. Okay. Today that we will talk about one of our works, that the spatial temporal analysis and some related technicals. First, we will give a quick glance at the background of this topic. Sorry. Then I will share our idea about how to handle such kind of spatial temporal problem and to provide some exploration and modeling capabilities. Of course, to achieve such kind of analytic goals, that we need some data preparation on the real spatial temporal data, and to make sure that to deliver a consumable data for the downstream analysts. At last, that a crime analysis use case will be used as the demonstration for our topic. It uses the crime event data with location at the time where the crime happened. Okay. Let's start from the background. Almost all the data are not the data themselves. They have some properties collected with them. For example, the time and the space information are always can be collected when the data are get into the database or something. Among these properties that we treat the time and the space information as the most important thing, because that gives the data their characteristics. For the spatial data, the data observed and collected with the location information in a geometric space. So the example can be the remote sensor data, or the monitoring data in different area, or the survey data from the different cities. For the temporal data, it is usually a sequence of data points that looks like a time series data. Example can be the count of the sunspot every year, or the daily closing price of a stock. So for the spatial temporal data, that it is enabled with both the time and the space properties. All the data have these two dimensions that can be treated as a spatial temporal data, just like what we will talk about today in our content. Okay, so correspondingly, that many analysis methods are already developed for these properties, for this data. For the spatial data, that the analysts will take the spatial distance into account, such as the spatial regression, such as the spatial autocorrelations. And for the temporal data, a time series method, a time series model can make use of the nature ordering of the data. It is express the values in a given time as dividing in some ways from the past values. Well, the spatial temporal analysis is a challenging topic here. Yeah, as it involves the concept of the system which try to catch the change through both the space and the time. So besides the data themselves, the analyst needs to consider three components here. The spatial domain, the temporal domain, and sometimes there also contain some external factors which could have the potential impact on the interested target. Okay. So here we try to classify the works according to their content and directions, because there are too many work can be done in the spatial temporal domain. in your left-hand side, that the tool part explore some easy understanding pattern and display them in some formats, while the right-hand side tool part focusing on the formulating such kind of patterns and apply this formulation to forecasting for the future situations. You can see that some common ideas are also can be applied in this area. In the exploration phase, that association rule, the segmentation method, and in the visualization, we use some dynamic heat map, some object overlay to help user to understand what happened in their spatial temporal data. And for the modeling and the prediction part, we have some kind of pattern extraction method for them. Here also some prediction one. Okay, so based on this analyze area that we provide some method to handle the common business scenario in the spatial temporal situation. They can provide the exploration modeling capability based on your spatial temporal data. Such package, we call it STEM here. Yeah. Here is a very simplified flowchart for the STEM. You can see from the bottom to up that you can find how the data are transformed into analytic and visualization result. For different kinds of data source, spatial data source component is in charge of the access this data stored in different format, in different database or different shape field. And some data transformation work need to be done before the analysis and display here in the middle. And in the analyst domain, that the modeling, prediction, visualization kind of things that will be generate the statistics information for different analytic requirements. Okay. So within such spatial temporal architecture, that we can provide several kind of analytic modules to address the different requirement against the different data source and different user scenarios. In the upper left, for the point data with time and space properties, generalized spatial association rule can be used to find out how the point data or the event that happened with their time and location. It's a kind of that the extension of the traditional association rule but it connected the data with their time and their location informations. In the upper right here, we do some segmentation work, try to follow the traditional data mining method. If there are thousands or tens of time series collected in the same time span, such as the product line monitoring data, can be analyzed together. It can help to find out a series with similar pattern over time and try to group them together. Okay, about two methods here. About two methods up here are mainly focused on the exploration and the two methods below are focused on the modeling. The spatial temporal prediction method can handle the data in a set of fixed location in 2D or 3D spaces. And it's expected that the data collected in equally spaced timestamps across all the locations, such as the day 1, day 2, day 3, and so on. And a model can be built for the numerical series data. Then future value for the for any location can be used to do the prediction. In the right, the point process model are focusing on the point data or the event data, but such data should be aggregated into the regular data before we use it. Yeah, and the fixed it should have the regular data with the fixed location and the easy and the equally spaced timestamp. It is difficult to do such kind of things, so we will involve some data preparation work later. Here, I want to just mention that this two part has different data assumption with the spatial temporal prediction, the point processing model and the spatial temporal prediction with different assumptions, because that the last model are based on the point or event data and can issue the event count at a specified location for future times. Okay. So to accomplish this analysis work that we just mentioned, we need to do some data preparation functions to support them. Look at this workflow that we start from the raw data, from the user's raw data here, the raw spatial temporal data, and there could be multiple data sources with different data format. Several kinds of pre-processing work are supported here. For example, the spatial projection in the middle part, the spatial projection, the geocoding, the data aggregation, and so on. And I'm not list all of them. The main purpose here is to merging the spatial temporal data with the traditional tabular data, because that the common data mining method or the MLab method are mainly focusing on the tabular data. So we merge them into a tabular data, and finally we can give a model-ready data for downstream analysis. Okay, go. For the input data for the data preparation, that usually the customer can have data like this three kind of data, and they have data maybe in the similar content or the format, which can be transformed into this type. Yeah. For the regular data, which is just like the common used tabular data. In our case, that it can include the geographic information and a little bit small. Each record can present the information for one regions at one time. Yeah. And for the point date, it gives when and where it has happened for every event, for every crime. Yeah. The last but not least, the geospatial layout data describes the boundary of the regions, and it can be include some statistic information to help the model to understand each region. Okay. So we packaged all the mentioned functions, packaged these spatial temporal data preparation operation together, and the caller to use our package can use them depend on what kind of data they have. Of course, some of the input are optional. That depend on user scenario, and they can configure the transformation function based on their needs, based on their data situations. Here, just list some common. The dot here means that that's not the required, but depend on user state. Okay, so all the work mentioned that this work has been done in Java, but we also offer the Scala API for the people who want to use our package. You can see that there are data preparation, spatial association, segmentation, just like the clustering, and also modeling, prediction package we just talked before. And use this API are very simple. Just import the required package and call the function you want. The usage is similar as the MLab functions. Okay, so after talk about these technical details, that here we will give an example for you to consolidate them and to take away. Here, I'll give an example that the police department in a city want to predict the crime event for the next several years. It can in order can help them to better plan and allocate the resource, police resource. What they already have for the analysts can include this part. The geospatial data, which defines the census tract of the city, and the past crime records include the time and the coordinates of crime event. Also, some local demographic profiles include the population density, include the per capita income, diversity, middle age, or the male to female ratio. They are all the potential factors that maybe can infect the crime. Yeah, so all this information can put into the model, and the model can answer that which one is important and which one is less important. Yeah. If you look at the map, you will know that it's the large Georgia in US. Yeah. And all these data sources need to be fed into the data preparation, just as we mentioned that. There will be special information extracting from the data, and the crime record mapping into the census tract. We will collect it and aggregate all the crime in each census tract, and merge all them together. The model ready data will be in tabular format, just as we mentioned before. Okay, so that's what the prepared data looks like. You can see that the time index here, we already encoded the time point. And when we aggregate the counts, occurred in one time interval. Yes, the time interval are predefined, determining on the analysis area you want. If you want to analyze the date by date, you can simplify use the daily cut point. If you want to predict the monthly by month, you can use monthly as a single time interval, depending on your usage. And here, the longitude and latitude are used as the location information. And for the input here, for the input for the date, and there are demographic information treated as the external predictors and will be included in the model. Yeah, the crime, the last column, the crime count are the target variable that will be used as our modeling purpose. Okay, so first we do the data preparation, so you can see something before you do the modeling. Try to understand what the data look like. Yeah, here I want to mention the one concept is the intensity. It is a kind of the measure of the event counts per unit area, because that we are not focusing on every crime event. We just focus on the trend of a region. Yeah, and the region are defined by the census tract. So the prepared data can be used for visualization to explain how the crime in this city looks like. And show here that each map is a static chart that show how the crime events are distributed. Well, for the track, that it also has a dynamic process. Because that we have we do this solution for the police department, so we cannot get the newest data. We just use some historical data to demonstrate our capabilities. So the data looks like a little bit older, but the method is new. Yeah. Okay, so here you can see that the track 24 can be shown in a Times Square chart. Yeah, this data is prepared data. And the crime control, here is a change point that In the last 2 years, the crime control was better and better, and can help them identify their operations. And with all these data, that how to modeling with the spatial-temporal data to find the patterns. Here I am not going into the detail of the modeling, just to show a structure of the idea we have done. And first layer on the top side, and it is about the input and output. The model-ready data we mentioned that we already prepared them. And the output is our model result. You can see that it's kind of a collection of the statistics. Yeah. And the model can be shown in a 3-layer below. From here, the 3-layer below. And according to the analysis purpose, the external factors, the time series autocorrelation, and the spatial correlation, each of them are handled by one layer, and they are nested one by one. And for the second layer from the top, the influential of this layer, the factor analysis layer, it handles how the external factors influence the crime. This layer uses linear regression to connect the external factors, such as the demographic profiles. And for the third layer, the time analysis, the third layer, it handles the time dependence, give a first estimation in step 2, and then give a refine in step 4. Here we use some kind of like the AR model, the auto-regressive models, which is built based on the regression residues, and which show how the value are infected by previous values. And for the last layer, the spatial analysis layer, and this step here focus on the spatial relation constructions. It constructs a spatial correlation matrix to describe the influence between every two space blockers. Yeah, we actually built a very large matrix for each of them. Yeah, and the step 1, 2, 3 in the left hand, give the first estimation for the corresponding part, and then the step 4 and 5 in the right will refine them. So actually, this kind of process can be iteratively processing, but that we after our examination that we found that there are not needed too much tuning. Just one iteration is enough for the prediction. But if you have enough resource, it can be run several times to give a more accurate models. Of course, that the more iteration means that more time consuming. Yeah. Okay, and so a model is built based on the previous sliders. So here we got the result, we got the model result, and such kind of model can apply to predict, can do the prediction to get the crime count for the next few months. So if we look at the example in this chart, that the next month map for the crime intensity is look like this, and there could be two tracks. Two track place need to pay more attention, and the police department need to put more force in these two areas, which is different from their history behavior. Okay, and last, and that we will give a kind of what-if analysis, which means that you input something with your expectation, and we can give the result based on the model. Yeah, suppose that such scenario that there will be a large sports festival will be held in this city, and the police department wants to estimate how the crime will be changed, how the crime, maybe there are some tracks will have more crime happened. So because that based on their experience, there could be large amount of people flooded into some area, and the sports fans are mainly males. So with the prediction result map comparison before and after, so the crime in some sports-related area will be dramatically increased. Such kind of what-if analysis can be broadly used in, for example, in the manipulate the controllable factors for abnormal situation intervention, such as to identify the potential risk before the breakout. So it can help to reducing the expensive recovery action to help to reduce the cost. Okay, so that's all for our presentation. So thank you.
Are there any questions?
I have curiosities, not quite questions. So actually, I'm interested about the features in the input of your data. Mm-hmm. Okay, can we discuss about, let's say, about education, about historical data? It's what's the influence of historical data, like 20 years back in time? How that influenced the current results? Maybe that population change in that place. Maybe their education, maybe their income, maybe there are other features in your model that can change the number of crimes in that area, or I don't know. So actually, and the next question is, how can you identify the triggers for the criminality in that area? So maybe you, after analyzing the data, if you have the possibility to say, okay, maybe education and lower income is, they are represented the main triggers of criminality.
Okay. Let me try to answer your question first. First question, and about what kind of external factors can be used in our method, or maybe there are in the customer situation there are several, maybe thousands of factors can be used. Actually, that whatever the regression model or the time series model we used, we all have the feature selection style-like features to help user to identify which factor are more important than others. Yes. Maybe our model cannot directly answer the questions, but that after the model building, we will show some parameters, show some, we call it the predictor importance to help to understand which factor have the higher rank, higher score to help you to predict your predictions. Yes, so maybe after that, the user can based on these ranking scores to do some feature selection by themselves. Also, maybe can do some automation process to filter out the unimportant factors and focusing more on the important ones. Yes, I'm not sure I'm answering your question. Okay, thank you.
I have a question. When you're merging multiple data sources, often you have like different resolution of spatial values or different time coverage. Mm-hmm. Did you also have same problem, and how did you tackle this problem?
Yeah, actually that for the spatial and the time, they all can have different kind of skills. Yeah, for example, just like I just mentioned that if you want to focus on the day-by-day prediction, you want to check the next few days, you can merging your date day by day. For each day, you can aggregate your crime or your count or a transformation or something into day. That model will focus on the day by day. If you want to focus on long-term trends that month by month, for example, of course that you need to use the month as a time interval and aggregate the date into each bins. Each bins means that each month for them. Okay, so this model will be focused on the long-term tree. But how to merge such kind of result that depend on the downstream entities, the reasonable. Or we also try to add some seasonal patterns, because you know that time series area are very care about the seasonal patterns. What about the exponential smoothing, about the ARIMA model? They also have the seasonal patterns. But here now, it's the first version for the spatial tempo. We do not take care about it. But in the next, we think that we can do some seasonal consideration to incorporate this seasonal pattern. For example, this year, now this month maybe depend on the month in the past year. Yeah, such kind of things.
Okay, last question.
Okay.
Please.
Whichever.
Okay.
In your API, do you provide any checks for overfitting of the models themselves? I mean, do you give the users an information about how good the predictions are in terms of cross-validation or some kind of understanding of the uncertainty? That's the first question, I guess. It's very simple. And did I understand correctly in your last case study that basically you said that you go and change the female to male ratio, rerun the model, or just increase the population and you get the difference by the influx of this festival or whatever? Is that how you perturb the model and come up with the increased level of crime or not? Which, if that was the case, it doesn't sound very reasonable to me, because you inflate the population, you change the male to female ratio of something different than the festival than what the primary variables were. But
Let me try to answer your second question first. Yes, actually, that for the what-if analysis, it is dependent on the policeman's expectation. Depends on their experience about how such kind of big sports festival happened. About the male-female ratios, that usually they can give some assumptions, and maybe based on some hotel reservation, some kind of thing to get some related information about it. Yes, maybe not that exactly, but it will be close in your situation. Yes, and for the first question about how to evaluate our model, right? How to we did some model evaluation things that to help to evaluate the model's performance, such kind of. For example, for this case, that we can simply treat it as a regression problem and use the MSE, some kind of regression errors to help to understand that what kind of errors between the expected values. Because in the historical data that we are exactly know what is the crime, what is the number of crime, and we leave a little bit test period to predict them and try to predict by ourselves and compare with the observed data. We can know what is the error of our model that are durable. But you mean that for the cross-validation, so far we don't provide that. But I think that it is kind of structure that to call our model as a subcomponent and do the cross-validation several times, and based on each subset and collect them together, can easily get the result, I think. Okay.
All right, thank you, Jingzhu.